Hi everybody, I am Sajad Moradi and welcome to my video which is focused on the statistic parameters. Today I will be exploring how to calculate and write statistic parameter in the three different programming MATLAB, Python and the Julia for first time. In this lesson I will focus on the learning how to use the PDF. Actually, in this video I want to introduce the new distribution, which is gamma. Firstly, let's focus on the definition for the gamma distribution. Gamma distribution is the continuous probability distribution that is widely used to model waiting time over the time until a certain number of the events occur in the Boston process. This image is allocated to a gamma distribution, which show the three different shape of the gamma distribution, which related to this difference of the shape is related to parameter in the gamma distribution. Additionally, it is also useful for modeling skewing data, such as rainfall amounts, insurance claim, and the financial data. Let's back to gamma parameters. There are two parameters which control the shape of the distribution. K as denoted as the alpha and the beta. This form of the function related to PDF, the probability density function of the gamma distribution. So for this, I want to work on the PDF for the gamma distribution. Actually, we now have a simple example of the gamma distribution that provide a valuable insight and the best insight into its concept, actually gamma concepts. Example is that suppose the customer service hotline receive and the average of the two call every 5 minutes, and our aim is that we want to use the gamma distribution to reach this aim. We want to model the waiting time until the fourth call arrives. So our parameter is that gamma and theta and alpha. Gamma is the rate of the calls. It's mean to call in 5 minutes. That equals 0.4 calls per minute. And we want to find the waiting time until fourth call. So alpha equals 4. This is our aim. The scale parameter is theta, is the 2.5 minutes per call. And distribution, the waiting time follow a gamma distribution with alpha and the theta. And the calculation for mean and the variance. Mean is the 10 minutes and the variance of the waiting time is the 25 minutes. So we use the PDF to find this aim is the model the waiting time until the fourth call arrive. To find the probability that the fourth call arrives within, say, 8 minutes, you would need to integrate the PDF from 0 to 8. So we use that 0 to 8 for the fourth call arrive. In the next step, we want to code this example in the MATLAB, Python, and Julia. In this step, we want to write MATLAB code for our unique example, which I spoke about that in the previous slide. So for this, firstly, I write a CL clear to start, clear closal CLC. Actually, we can write this before this code CLC, and run it. And I want to define parameter, which was alpha and theta. For our example, we defined a new variable alpha equals let me to change font. I think it is another font is better. Actually, I think it is better. So I defined this. This is the alpha, which was 4% for our command. Shape parameter. Alpha is shape parameter, and another parameter is theta equals 2.5. I want to change. Then is the theta is a scale parameter. And in the next step, I want to generate random samples with the gamma rand function in the MATLAB. So I generate I write a comment generate this. It must be capital. So my sample, the number of my sample I want should be 1000. It is okay for our example. So for this, I define num s equals 1000 samples, and I use the GMD or the GM R&D, or you can pronounce it however you find it most comfortable. So I take a GM S equals, I use the GM R&D, actually change the correct form of the function in MATLAB. And first I use the alpha, comma, and data, which previously we defined 4 and 2.5, and comma, and the number of samples which we want to generate, which is the 1000 S and 1. You can use the doc function, doc code, to find more information about this code, this function, MATLAB function, and use it. So I want to run this part of code to see that actually just run, and I want to show result in the command window. Actually I write wrong this form. Yes, it is it's all data and the samples which generated by the gamma random function in the MATLAB. So in the next step I want to plot this samples with the histogram. So I write plot the histogram okay, and I use the histogram function, histogram function, whereas out samples GM S, comma, I want to normalization first, normalization. This comment first the normal to normalization of samples, and show it, and the form PDF probability density function. And in the next code I want to hold this figure for next operation. So I run it again, as you see, this form of our histogram for our sample which create with the gamma rand with the two parameter, specific two parameter alpha and theta for 1000 samples. In the next step I want to create a line for our histogram PDF lines actually. So firstly I write the comment for this, plot the PDF probability density function. Actually it is not true, plot the PDF. So I define the x for as a variable, and I use the line space line space used to create a 100 numbers between max, mean, and max of the mean of the all gamma samples, and then next parameter is max of all samples which created by the gamma random R&D, actually GM R&D, and 100 numbers. If I run it, this section, the result is the 100 number between 0 and 32.47. Actually, in the next line I want to use the GMPDF, or actually a function which create the PDF by gamma distribution. So I write this GAM gamma PDF. This is the variable, and I want to save the result in this variable, and I use this function PDF, and I use the x 100 numbers for this function, and alpha comma theta semicolon. And next I want to plot this result on the all histogram in the previous section. Actually use the plot x is the minimum, is the number of 100 number of samples which created, and then next step I use this, and I want to show the line red and comma line white I want to be 2, and hold off. So I run again this code, as you see this is the PDF gamma PDF, this line for all samples. And in the next line, I want to calculate mean and variance, like our slide, which I explained about that. So I define the mean v. Oh, actually, firstly I write the comment calculate mean and variance. So I define the mean v as a variable for say the result of the mean, and semicolon, and variance. I think variance is incorrect. Equals and in the next line I want to show result. For that I use the f print f rest. This is the comment for mean, and use a percentage for the show the number of 0 and comma, and the result is I change it to mean v, and in the next step I want to show the variance. Print f actually I use the comment I want to use the clarification of this result. Actually I variance v and v. So run again this code. Actually you can see the result of the mean and the variance. So if I use the for and the for test, we see the change in the result. As you see, we have a 4 0 after the point. Okay, and in the next line and the next step in our writing code, I want to calculate the CDF. CDF is a cumulative density function, and I use the AMCDF function to reach our aim, which was 8. I write the calculate the CDF, and I use this function variable definitive variable CDF v equals change CDF and 8, which define our example, and alpha theta and comment t x. Actually, and I want to show the result, and if print f command CDF at x 8 as the percentages 0 for f n comma and result CDF v. So run again. As you see, the result is that this is our samples and the PDF line, and the result for the 8 is for the mean 10 and the variance 25. In this session of this lesson, I'll use the spider space to Python for running of our samples, and next I import the tree library. First import numpy as np, and second import state as a state, and next import MATLAB dot pyplot as a plt. Change here and run. Actually, in the next step, I define the parameters. This parameter is, I write a comment parameters, and alpha equals 4 and theta equals 2.5. 0.5. And next I want to generate random samples with gamma distribution actually. So for this I use a random samples. I define new variable num underline s equals 1000 and comma underline s. I use the state dot comma dot vs alpha comma scale theta comma size equals num s. So for this I run this section. Okay, yeah, so I run again this section. As you see, we have alpha integer and theta float and 1000 numbers for the all random samples, and we use this function for generate the random samples. In the next step I want to plot the histogram and the probability density function. For this I write the command for this operation: plot the histogram and PDF. Actually I use the capital version PDF and plt dot is bracket and I bracket comma my random samples. First the bin is 30 and density true and alpha sex call equals green. And we change this added equals and change to true. Actually it is correct. And next I define the x as a new variable and use a numpy np dot space and 0 for minimum, and max is for comma underline s and 100 numbers, and for comma I define PDF as a new variable. I use the states dot comma dot PDF x alpha alpha and scale theta. And in the next line I use a PLT MATLAB clip that plot x and comma underline PDF and color red and line equals 2. Next plot dot show PLT dot show. So I run again this section. As you see, this is our figure for our random samples, and I want to show and I run again and find that error for our codes which don't show PDF lines. So I change it and run again. As you see, this is the random samples and the PDF line for our random samples. Next, I want to calculate the mean value, mean and the variance. So first I use and write mean and variance and define the mean equals state. I use the state dot comma dot mean and as the two parameter alpha a and scale equals theta. So for variance actually variance equals states dot common, I change it, common dot var bracket a equals alpha and scale equals theta. So I want to calculate this, run. As you see, mean is 10 and variance is the 25. These are calculated by a state. Actually, in the next step, I want to calculate this cumulative density function for our assumption and based on our question. So I write a comment, calculate the CDF. For this I write the CDF and then unknown value. I use the states dot comma dot CDF for our number. Our assumption is 8. A is 4 and scale equals theta for P bracket X less or equals than the 8 and next print f CDF at x equals 8 is CDF underline B 0.4 F. Actually delete this and add it in this section. For I run again, we have our figure for samples, random samples we generate with the gamma distribution, and the result of for our assumption in our question is the x is 0.39 In the next programming space, I want to write a Julia code for our example. Actually, like Python, I must use the package. For Julia, I will use the distribution package and the plots. For I write using distribution and using plots, and I change it and run. Okay, it's true, and I want to define parameters like the previous programming, MATLAB and Python. So I use the para and alpha equals 4.0. Actually, it's 4 is enough, and theta equals 2.5, and run again. Okay, so for this I want to write print for show alpha and theta. Actually, I use the quotation and the space and run. As you see, 4 and 22.5. And in the next step, I want to generate random samples. I define the new variable number of samples equals 1000, and I use rand, so I defined comma s equals and comma underline actually in that previous step we create a comma distribution object, and is comma. If we want to use a rand function, we need to gamma distribution object in Julia. So for this we define the gamma d to create the gamma object, actually gamma and theta. So, and I use this comma d and the number of samples and on the line s, and run. actually this is a result of this function, rand function, with a 1000 number of samples. And next I want to calculate actually plot histogram and PDF. So I write a comment, plot the histogram and PDF. I use the histogram function, histogram function, press the comma, underline samples, and normalized PDF, column PDF, and the number of bin is 30 bins, 30, with the alpha equals 6, and label quotation histogram, and I used x as a define as a new variable, range between 0 and maximum comma s comma len equals 1000, and plot exclamation mark x comma PDF dot comma underline d, this is comma object, and x label label equals PDF, and line width equals 2. Actually I run it, the xpdf comma distribution and label and length line white equals 2 and color is red, and run again. As you see, this is all histogram for all data with the PDF line. And in the next step I want to calculate mean and variance, mean equals mean comma d and variance equals var comma d and run. We must add the another word and the number to define another name for the mean, because this is similar to mean function, and it is we have a problem and error for that, so I change it and added the one here and run again. Actually mean is 25, and I want to print this. I use the print L N and mean and mean 1 and print ln variance run again. As we have a error, we must add the comma there and run again. As you see, the amount of mean and variance show here, and in the next step I want to calculate CDF for our assumption based on our question. At the CDF, change it. CDF value as a variable, and I use CD function underline D, our assumption of question 0, P probability for X equals 8, print ln CDF at equals 8 and the comma CDF underline yes. I change it and we actually run it. As you see, CDF at 8 is 0.39. Thank you for watching my video, and